Okay, now we're going to combine this jet stream idea with ocean currents and take a look at a very interesting phenomenon we call El Nino. El Nino is an event that occurs rather irregularly, as it were, and I'll show you, I'll give you a historical look at how often we have them. But let's talk about what it is first. Or let's talk first about normal conditions. Okay, I'm going to go over to the big world map again. Give you the big picture. Normally, in the Pacific Ocean, and it's primarily a Pacific Ocean event, normally in the Pacific Ocean, the water flows this way because the wind blows this way. The equatorial winds are blowing this direction. So remember, so if the wind's blowing that way, the current's going that way, all right? So normally, the surface water is blown from South America, or from the Americas, across the Pacific to end up over here in Indonesia. And that's surface water. And that surface water is very warm. So all that warm surface water piles up over here. You know, it can't really get too far past this area because this land acts like a dam. As a matter of fact, so much water piles up over in this part of this side of the Pacific Ocean, in the Western Pacific, it's higher. The sea level's about 1 foot higher over here. It's called the Western Intensification of the Pacific Ocean. So here we go, water piling up over here, but it's very warm water. So climatologically, if you got really warm water here, you get lots of evaporation, condensation, and rainfall. That's one of the reasons it's such a wet area, because it's usually surrounded by very warm water. So staying with these normal events, if we're taking all that warm surface water and blowing it this way, we get upwelling here off the west coast of Peru and Ecuador, just like we do off California. So we get this very cold water, usually off of the coast of South America. Now, another thing that generally occurs with cold water upwelling is it brings a lot of phytoplankton and let's call it nutrients and food for fish. So areas of the world where we get cold upwelling currents, we generally find large schools of fish, and we do here. One of the species that they go after here in a big way are anchovies. Most of the world anchovies come from this area right in here. So anyhow, now, so that you got normal conditions down, right? Normally, wind and water blow this way, cold upwelling water here, very warm water, lots of rainfall here. Those are normal conditions year after year after year. But every few years, we get something else going on. Let me put that slide. This is showing you normal conditions here. Let's take a look at what we call El Nino conditions. Back to the map. Well, El Nino conditions, you guys, let's just reverse the wind. Why? We don't know. We haven't got a clue. Okay? Wind reverses, but if the wind reverses, so does the current. So all of that warm water that had been piled up over here, that warm surface water, it gets blown all the way across the Pacific, hits the Americas. Now, in situations where you get a very strong reversal like this, that warm water hits the Americas and then just spreads out and can come all the way up into the Gulf of Alaska. Okay, now, we should talk about the name. El Nino. Okay, now capitalize the N in Nino. What does that word mean? What is El Nino? Well, if it was a little n, it would be. Beth's just chomping to get it out. Beth, what is El Nino?
I believe it's the Christ child.
It is the Christ child. So when we capitalize Nino in Spanish, we're referring to the Christ child. I know you look very puzzled. Why? What's going on here? Okay, here's the deal on this. One of the first times one of these situations, reversals, was recognized was the Peruvian fishermen were out here, and they usually go out in December in the wintertime. They're out there in December. And they go out there. Number one, there's no anchovies. Number two, wow, this water's warm. It should be freezing. So they called the arrival of this warm water occurred near Christmas. So they just, let's call it El Nino, it's the arrival of the little Christ. And I don't know why they did that, because it was an economic disaster for them, but whatever. So the name stuck. So whenever this reversal of warm water occurs, it's labeled El Nino because the first time we saw it, it occurred around Christmas time. Now let's talk about what happens meteorologically when this El Nino event occurs. Let's start off over here. Now remember, all that warm water is gone, replaced by cool to cold water. cold water now, getting very little evaporation, very little condensation, few clouds, very little, if any, rainfall. It's a meteorological disaster when we have El Niños for this area. The reason is severe drought. These are islands. You know, they rely a lot on runoff, rainwater for their fresh water. They have a lot of freshwater resources. The other issue is these tropical rainforests depend on continuous rain. If you get a long period drought of months, the forests dry up, we get huge fires. So we get forest fires, we get lack of drinking water. It really is disastrous to get a severe El Niño event for this area here. Okay, so it's terrible for them. How about us? Well, it kind of depends where you live, but where we live, we love them, and this is why. If you get warm water moving over here and spreading out, remember, one thing to think about here, when we warm ocean water up, we're getting a lot more evaporation, okay? So first of all, there's more moisture available in the atmosphere. The second thing I'm going to show you is that this warm water displaces both jet streams, the polar front and the subtropical jet, okay? And let me show you the map up here. Skip down, we'll come back to that. Here you go. Take a look at this map right here. Normally, this is the subtropical jet. This is the polar front jet. Normally, the tropical jet would be well south of this area in the wintertime. But the warm water displaces it, moves it north. So the jet stream flows across the southern part of the United States and northern Mexico. You know, so what? Well, any location that the jet stream goes, and like I said before, any storm underneath it follows that same path. So the point is, this jet stream, if it stays in this position for a long time in our winter, it's going to carry storm after storm after storm going by. Now, I counted, we had 7 low pressure systems go by this winter time. But all of them, almost every one of them, stayed well to the north. Actually, they were coming in on the polar front jet. Normally, that polar front jet would be much farther south. So this winter was a pretty normal winter. So the polar front jet's coming across like this, and we just get brushed by these low pressure systems. Yesterday, remember it got really windy, you saw those ugly clouds, you see any rain? No, we didn't get any rain yesterday. It stayed just to the north of us. That's pretty typical for us. But this year, on these years, the El Nino year, that polar front goes way north, but here comes the subtropical jet way further north than it usually is. Okay? So we tend to be very wet and cool across the southern part of the United States. Now, other parts of North America don't get that kind of weather. For example, up in British Columbia, well, actually, from the prairies west and all of northwestern United States, if the polar front is up here, they're in very warm here. So they tend to get very mild winters during El Nino events. So, you know, people in British Columbia applaud the arrival of an El Nino. At least I do. We like warm, mild winters up there. Usually get a lot of snow as well if you can. Okay, let me go back. Oh, wait, hang on. Oh yeah, we didn't talk about one other issue. Right. Now, you've heard of La Nina? Yeah, 3 seconds. You've heard of anybody? La Nina? Okay. So La Nina, what's La Nina?
Mary?
Mary. I actually don't know who, no one knows who La Nina is. We just decided, not me, I had nothing to do with it. It was decided to use the term La Nina because it's the opposite of El Nino, and it is. What is La Nina? Let's go to the big map. La Nina is, think of this, normal conditions on steroids. Normal, really strong winds blowing over toward Indonesia. Much stronger than normal winds blowing over toward Indonesia. So you get much more upwelling of cold water, colder than normal water all through this area, and warmer than normal water over here. So they get an increase in rainfall. They'll get above normal rainfall during La Nina events. Okay? We get cold over here in North. We get cold and we tend to get dry over here in North America. Okay? So El Nino events associated with warm water, La Nina events associated with cold water insofar as the Americans. All right. Okay. How do we know if we're going to get an El Nino winter or a La Nina winter? Actually, I'll do it over here, Beth, easier for because I like you to get this on the board. Okay, what I'm going to show you here is you see I got a 0, then I got +1, +2, +3. a zero line when we're looking at this is going to be normal sea surface temperatures, okay? This is in Celsius. +1 Celsius, +2 Celsius, +3 Celsius. These would be if we're getting above normal. We have buoys, okay? We have a series of buoys all across the Pacific Ocean here that are constantly measuring sea surface temperature. You can access them on the internet if you want to. And they're going to tell us if we're above normal or below normal. So for example, once we see sea surface temperatures getting into close to 1 degree above normal, that's going to indicate the arrival of a relatively weak El Nino. Remember, warm water, El Nino for us. So I'll just put this up here. El Nino in this area, above normal temperatures, and La Nina is going to be associated with below normal temperatures. All right? So that's why we measure the strength of an El Nino event. If you're +1 above normal, you got a relatively weak El Nino. 2 +2 degrees above normal, you're getting a pretty strong El Nino. And +3 El Ninos, we've only had a couple of those, 1983, 1988. These are very major El Nino events. On the other hand, once we get down close to 1 below Celsius below normal temperatures, we're getting into a La Nina. Same thing. So the further below normal we are, the more intense the La Nina event. The further above normal sea surface temperatures are, the stronger the El Nino event. So let's get to your question. Oops. Okay. This is a graphic going back to 1950 of just exactly what I've put on the board. Okay. The 0 degree line are normal ocean sea surface temperatures out in the Pacific. You can see departures from normal over here, +1 Celsius, +2, +3, -1, -2 Celsius over here. So I want you to first look at from 1950 just up into the mid or late 1970s, where my stick ends, okay? Can you make any statement about the occurrences of both?
La Nina are more frequent.
Yeah. We had many, many more cold water events from 1950 to 1975, right? Okay, now take a look from 1975 up to about 2006, where my hand is. You want to go from here to here. What do you see in terms of frequency of events? What's that? Look at all those. Look at all those El Nino events. Here's the one that almost took out the Glen Canyon Dam, right? Back in 1983, look at that. We were getting up to 3 degrees above normal. Same thing in 1998. These were the two biggies right here, the only ones that we've ever exceeded 3 degrees above normal. We had so much snowfall in the Rocky Mountains when spring runoff came, it literally filled the reservoir behind Glen Canyon to the very top. Actually, it went a little higher than that. And if you read the accounts of that, it's pretty thrilling, or not, that some people were suggesting that the dam might go. But it didn't, it happened. So anyhow, just to show you that when we get an El Nino event in this part of the world, we get a lot of snow, a lot of rain, a lot of runoff.
It's a 30-year period, right?
Well, there is something to that, isn't it? So we go from 1950 to, almost 1980, so there's about 30, maybe 25, 30 years. And then we go from, about that same time to here. But now, before we talk about that, what about since about 2006? We're flipping back. Well, I mean, here's the thing. We don't have enough data really to suggest we're flipping back. We got to talk to me in 20 years. Right? I mean, what's this going to look like in 20 years? I'd love to see it. But to me, this begs the question, where are we at right now?